This is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 7 topics. The first topic, it's about Typst. Here, David and Dominic from Ost are working on their bachelor thesis, a collaborative editor for Typst. And as part of the project, they created a tour of Typst, this website here. This is an introduction for newcomers. So please, if you have time, check it out. And also I linked in the feedback in the following link here, a link to this form where you can fill out the form about this tour of Typst. And feedback is highly appreciated, especially if the students need to adapt Typst, the tour of Typst, before going live. The next article, it's about Docker in production. The article asks whether plain Docker Compose can run production workloads, and the short answer is yes, as long as you handle the operational gaps on your own. Docker Compose is a declarative way to wire up multi-container applications in one YAML file. The sweet spot in production is the single node deployment, a vendor pushing an application into a customer environment, an internal team running a service that does not justify a Kubernetes cluster or an edge box at a retail location. And there is no control plane behind Compose. The command runs once and exits, and the operator has to do the rest. And this article walks through the recurring tasks. Removing a service from the YAML file does not remove the container. It stays running as an orphan until you pass the remove orphan flags. Old images and unbound container logs fill the disk over time, so you need to cap log size in the daemon config and prune images on schedule. Health checks report status but do not act on it, and Compose has no built-in way to push updates to remote hosts. So at fleet scale, you need a pull-based agent that reconciles state and reports back. When Compose stops being enough, the article points to Kubernetes as a realistic next step. Docker Swarm reuses the Compose format and solves a few of the quirks directly, but adoption is not really a thing with Docker Swarm. And here is my point: keep it simple. Do not reach for scaling solution if you do not need to scale. A single node Compose deployment with the operational gaps closed is a valid production setup, and jumping to Kubernetes before you need it just trades one set of problems for a much larger one. And in my home lab, in a small deployment, I'm using Docker Compose as well for my deployment. The next article is about authentication. Here, the next article describes a small platform's journey through 3 authentication setups. They started with one provider that bundled auth and database, moved to a dedicated authentication service, and have now switched to an open source library that runs in their own infrastructure. The interesting is part why the second switch took years and what went wrong. The dedicated auth service tried to be both the user table and the session table. That worked for simple apps where a user only sees their own profile, but it broke down for a social platform where many pages list other users' avatars and names, and the provider's user data endpoint was rate limited to 5 requests per second across the entire account, so the team had to sync user data in their own databases through webhooks, and that created 2 sources of truth and a window during sign-up where a user existed in one but not the other. And the bigger problem was sessions. Cookie-based sessions are short-lived and refresh every few minutes, and the refresh went through the third-party provider. When the provider went down, the site became unusable even for users who were already logged in. The article makes the point that the reliability of a system is the minimum reliability of its critical part and not the average. The replacement is an open source auth library that runs in their own code base, so session management and the user table are back under their control. And a note on the technical choice, the library, they switch to uses database-backed session tokens by default, not JOT tokens. JOT tokens are available as an optional plugin, but the documentation states they are not meant as a replacement for the session. In our challenge task, JOT was mandatory, and the reason was the upside that the JOT tokens give you: stateless validation, no database lookups on every request, and easier scaling across services. The trade-off, which this article runs into from the other direction, is revocation. The next article, it's the following here. Here, the registry that runs Germany's .de top-level domain published broken DNSSEC signatures during a routine key rollover, and a large part of Germany's internet became unreachable for several hours. We talked about DNSSEC also in our lecture. DNSSEC adds cryptographic signatures to DNS responses. A resolver that validates DNSSEC checks the signature against the published key. If they do not match, the resolver is required by the specification to reject the response and return an error. That is exactly what happened. The signing process at the registry generated signatures that did not match the published keys, so every validating resolver in the world started rejecting answers from the .de zone. And the root cause was an internal one. The registry had recently deployed a new generation of its signing system built on standard software combined with in-house code and hardware security modules. The system had been tested and externally audited, but a faulty piece of code in the in-house part was not covered by the test scenarios and was not detected during cold parallel operations before going live. And here my point: the internet is unreliable. The 8 fallacies we talked in our lecture starts with the assumption that the network is reliable, and this incident is an example that this is a fallacy. The next article, it's the following here. It's about an incident. A viral post claimed that AI coding agent deleted a company's production database, and the operator tried to interrogate the agent for an explanation. And the article pushes back on the framing and points the blame at the system around the agent and not the agent itself. And the central question raised is a simple one: why does a production system have a reachable endpoint that can delete the entire database? If an AI agent had not called it, eventually a script, a misclick, or a junior developer could have. And the article closes on accountability. AI should augment competent engineers working inside a real process with reviews, permission boundaries, and proper backups, not replace it. And when a human uses an AI tool, the human is responsible for what the tool does. The next article, it's about stablecoins. It's the following article here. On-chain data shows that the issuer of the largest stablecoin froze more than $500 million worth of its token in the past 30 days across hundreds of addresses on 2 different chains. The pattern is not new. In the previous year, the same issuer blacklisted over 4,000 addresses and froze more than $1 billion worth of tokens. And this mechanism matters. The token contract includes an admin function that lets the issuer mark an address as blacklisted, after which that address cannot move its tokens. A second function lets the issuer destroy the frozen balance And of the funds blacklisted last year, more than half were later destroyed, and almost none of the blacklisted addresses were removed. A freeze is, in practice, here permanent. And the case behind the freezes range from suspected sanction evasion to scam investigation, usually in coordination with government agency and law enforcement. And here my point, this is not unique to this issue, to USDT. All major stablecoins, including USDT and USDC, all ship with blacklist and freeze functions in their contracts. So assets on chain is not actually controlled by the holder of the private key. And this will be actually topic of the upcoming blockchain lecture, where we also look into the smart contracts, how this blacklisting works. And now the last article, it's the following here. Here, this was sent to me by a former student. It is an open source book called WebRTC for the Curious, written by WebRTC implementers, and it focuses on the protocols and APIs rather than specific libraries, summarizes the relevant RFCs, and stays vendor agnostic. And since I have seen some of you working with WebRTC in your challenge task, this may be a useful reference if you want to go beyond the service of API and understand what is actually happening on the wire. So thanks a lot, Till, for this pointer. Highly appreciated.